Okay, looking at question 3, it says to find the gradient at those points. So of course we need to find the gradient. So dy dx, the differential of x over 2, or a half x, is a half. So I get a half e to the x over 2, and the differential of 4x is 4. And so looking at part A, it says at the point 0, 1, so that means when x equals 0, so dy dx, not dx dy, equals 1 half e to the 0 on 2 plus 4, gives me 1 half e to the 0 plus 4. And of course, anything to the power of 0 is 1, so I end up with 4.5 or 4.5. Part B, at the point 1 e to the half plus 4, we substitute in and I get dy dx equals 1 half e to the 1 over 2 plus 4, and that's my derivative. You could make it in decimal form, but I wouldn't. I'd leave it like that. So that helps you out basically. Question 4 is the same sort of thing. Okay, after reading it, I think we might actually put to don't do question 5, leave that out. It's just a little bit annoying. It's not that important, and you won't get anything like that in your exam. Question 6, so for example 6b, it's just finding more derivatives. E to the square root of x. Well, what you've got to remember is I'm going to let y equal that, and that's x to the half. So you just need to convert it into what it equals, and you might need chain rule because you have a function within a function for some of the others. So dy dx in this case equals a half x to the negative a half. Remember to bring the power down in front, subtract 1 to the power, and that's e to the x to the half. And so I end up in reality is 1 over 2 root x, because x to the negative a half is 1 over x to the half, and that gives me e to the root x, or you could write the e on top. Now, just want to quickly show you another one. That one was 6b, but I'm just going to do another example of what if I had y equals e to the 4x minus 2 to the power of 6. So what I'm actually doing is I'm going to do a chain rule to say we'll bring the power in front of the brackets, e to the 4x minus 2, subtract 1 from the power, and now I've got a times by the differential of inside the bracket. So the differential of e to the 4x is 4e to the 4x. Differential of minus 2 is 0, and so I end up with 24 e to the 4x outside of e to the 4x minus, the minus is actually in the middle, 2, all to the power of 5. Okay, enjoy.